Welcome to another tutorial on MatCalc. Today we will be learning how to generate a graph in MatCalc. For that we will be using the same calculation that we used earlier, because as I want to create a common ground for everything we learned. So I've saved my previous file as stepped equilibrium. That's what we learned. I'm gonna go with this. So we have these same 5 phases here. Well, if you want to delete any of these phases, if you want any of these phases to be not included in the system, and check how the system behaves when some of them is not present, in the system, you can always delete this or add another one. For adding them, you have to generate another database for that. Well, for deleting it, you get 3 different ways, which you can browse from. Global, go to phase status, you see these 5 phases. So one of the ways to delete one of these phases, or any of them, is to either suspend it, either remove it, or you can change the phase fraction to 0 and make it fixed for a certain phase. So let's go with graphite here. You can do anything for deleting it. You can either suspend it. Let's check what happens when you suspend it. You see that graphite is suspended, and whatever happens in the system is determined by only these 4 phases. Let's see another way. We change the fixed phase fraction to, let's set it to, it's already 0, so let's go with this. Now you can see the graphite was fixed. It is now inactive here. Phase status for graphite, the moles is 0 here, so you can see that graphite has no effect in the system now. The third way is to directly remove this. Okay, remove it. So that's how you do it. Now let's go with the topic. We are here to generate the graph for phase fraction versus temperature or the carbon content. Those are the 2 variables that we've been working with. So let's start with it. Go to view, go to create new window. We have to create the frame for the graph which we need to plot. So the graph is going to be XY. You can find it here, XY data, P1. Okay, so this is the frame where we're going to put the variables so that the graph is generated. The phase fractions here, you can see, is the variable in the variables window. So $$ is the code for this. You can either access this using favorites, phase fractions. So what you need to do to plot the graph is you just drag and drop it to the frame. You can see the graph for the carbon content variance from 0 to 1.5 with 800 temperature is plotted. When you change the buffer, you can see the graph change accordingly. So suppose you need to look more closer, you can zoom in or zoom out by pinching your fingers on the touchpad. I'm using the laptop, so. Or you can select a particular portion of this and let it go. Okay, so when you need to go to the original one, the original scale, you just right click. That's how you work with the graph. And now let's see the different options for this particular variable. This is temperature, and this one is phase fraction, right? So the range from 0 to 1 is obviously going to be phase fraction, so the default x data is temperature, which has the code $T. This is the same as writing step value by default. But suppose you need to change the scale here. This is in Kelvin scale by default. What if you need to change it to Celsius? You just write, you just add C to it and see the scale change. See? So if we're going to default, you just write $T$. Okay, so the default x-axis can be titled as temperature, the type linear or logarithmic, but linear is okay. So what if we need to change the scale of this plot? You just write the upper and the lower limits, 0.2 say, and add 2 dots in between the limits. You can see the change. Okay. The factor is 1 here. You can change the highest limit to 0.5 and see the graph change. The limit, upper limit to 0.5. Okay, so let's go to grid. Grid is basically for your convenience to define the x and the y values easily for a particular point in the line of the line. You can add major and minor axes. Grid to exist, first you need to use a major axis. So what if you use minor before major? Nothing happens. But when you use a major and a minor, you can have a pretty good set of grids. I don't need no grids here. The major pen is for the design of the grid. You can see the design change. Okay, major color is for the color of the grid. The minor pen is for the design of the minor grid. Minor color is for the color of the minor grid. So series. You know, the series are these phases here. So for a particular series, say FCC, you can change the styles here. The default style is the line. You can change it to some other designs like this triangle here by going to marker, the upper triangle to down triangle. The size you can change them, the colors and everything. Yep. The line. Can we change the sticks? For minor. Okay. I'm gonna go with lines, or just leave it to the default style. So that's all for the options. Not much to do with them. Okay, so what if you need to print this out to get the PDF file of this, or get a image file of this? You can right click. Oops. You can right click. You can either copy and paste to the specific software which support these formats, or you can directly export. The frame here and the plot here are two different things, because for a frame you can have a lot of plots like we have here. We just have a single plot for this frame. If you use a number of other plots, this frame can contain all the other plots. So when you export the frame, you are exporting the set of all the plots. But now we just have a single plot, so exporting either plot or the frame is the same thing. I'm going to go with exporting it to the PDF. Graph. So that's how we do it. Thank you.